Hey guys, just wanted to go through what we're going to be doing today since I'm not here. So make sure that you have Google Classroom open and take a look at the daily agenda. And here, let's take a look at it together. So what our plan is this. If you're at home, please make sure you did your attendance at Infinite Campus. Our topic today is going to be adding and subtracting radicals. So you guys just took a quiz on Tuesday on simplifying radicals, so that should be graded. You can take a look at my feedback in Google Classroom on that. And today we're going to be working on adding and subtracting radicals. So there aren't any guided notes. So please make sure you have notebook paper ready to go. And then once we're done, you're done watching this video of me going through the notes on adding and subtracting radicals. There's just going to be a worksheet for you to do. Mrs. Wonderlick is also going to be available during this class time. I will have her Zoom link posted for you guys. As well in case you're working through the worksheet and you're getting stuck during your class period. Okay, so let's move on to get some notes. So if you did not get a piece of paper yet, please do so. And please label your paper adding and subtracting radicals. Okay, so we got that labeled. All right, so next here we're just going to go through the steps. So step number 1 is going to be to simplify each radical. And you do that the same way that you just did your quiz, okay? And we'll go through what that looks like as well. Step number 2 then is going to be combine like radical terms by adding or subtracting what I like to call the coefficients. And we will talk about what that actually means as well. There we go. Okay, so just 2 steps here. All right, so hopefully you have those written down. If you don't, take some time to pause it and get those written down. And then we're going to move on to our first example. Okay, so first example here, 5 times the square root of 2 plus 3 times the square root of 2. So it says the first thing we need to do is simplify each radical. So we're looking here. All right, if I would go and try and break down this 2 and do like my little tree here, I would get 2 and 1. Okay, it can't break down any further than that, so that means that the 2 cannot be broken down. So that problem cannot be simplified. We come to the next one. That one also has the square root of 2, cannot be simplified. So now I can move on to step number 2. Combine like radical terms by adding or subtracting the coefficients. So let's start with this beginning part here. Like radical terms. What that means is that we need to look underneath the square root sign. Since both of them are the same number, that means that they are like radical terms. And then we need to add or subtract the coefficients. When I say coefficients, I'm talking about the numbers that are on the outside. Okay, so since the numbers on the inside are the same, I can now add the numbers that are on the outside. So 5 plus 3 is 8. And then since I have the same number underneath the square root sign, I just bring that down, and I get 8 times the square root of 2, and we are done right there. Okay, let's take a look at the next one. Next one here, we have 5 times the square root of 3 plus the square root of 12. Okay, if we look here, it says simplify each radical. That's our first step. So if we look at our first one, nope, that does not simplify any further, because if I would go and try and break down that 3, I'd only get a 3 and a 1. Okay, and that tells me that since it's already, I can only break it down by 1. Okay, that tells me that it can't be broken down any further. So let's move on to the next one, square root of 12. That one can be broken down. Okay, I'm going to break this one down between 3 and 4. 3 can't go any further. 4 can get broken down to 2 and 2. And now I can do my chart of my pairs and my leftover. Okay, I can see here that I have a pair of 2s, and then I have a leftover of 3. Okay, so that can become 2 times the square root of 3. Okay, so I'm just going to write that underneath here. I'm going to write 2 times the square root of 3. And I'm just going to bring my first term down, 5 times the square root of 3, because remember, that one didn't simplify at all. I'm also going to bring down my plus sign. Okay, now I'm done with step number 1, so I want to move on to step number 2. I want to look. The numbers underneath the square root are now the same. So that means I can now add these two things together. So I have a 5 and a 2. 5 plus 2 gives me 7. Since it's the same thing at square root of 3 here, I'm going to keep the square root of 3, and that's my answer. Okay. All right, so let's work on another one. Okay. Um, 8 times the square root of 5 minus, oops, let's write that a little bit better, 3 times the square root of 20. All right, let's take a look here. So first problem here, 8 times the square root of 5. If I would try and break 5 down, 5 can only be divided by 1 and itself. So that means that doesn't simplify any further. 20 though, 20 breaks down. I'm going to break down 20 to 2 and 10. Now remember, you don't have to use 2 and 10. You could have used 4 and 5. But I'm just going to use 2 and 10. 2 doesn't go any further. The 10 breaks down to 2 and 5. So now I can do my chart of pairs and leftovers. Okay, I have a pair of 2s and a leftover of 5. That becomes 2 times the square root of 5, but hold on 1 minute. I cannot forget I had this 3 out in front. Okay, hopefully you guys remember that you need to multiply the 2 of those. So that's really 6 times the square root of 5. Okay, now this first term here, I didn't do anything with, so I can just bring that down. There's a minus sign there in that original problem, so I'm going to bring that minus sign down as well. And now I can move on to step number 2, looking to see, do I have like terms? And the answer is yes. I know I have like terms because both of these have the square root of 5 underneath there. So that means I can take the numbers out in front and I can now subtract them. So 8 minus 6 gives me 2. And then I can just bring the square root of 5 down, and that is my final answer. All right, one more problem that we are going to do here together. Okay, so we have one more. 7 times the square root of 5 minus the square root of 32 plus 3 times the square root of 45. All right, so as we can see here, now I have 3 terms. Does not change anything. I want to simplify each of them. So if I'm looking at this first term here, 7 times the square root of 5, that cannot get broken down any further. If I would try and break down the 5, 5 can't be broken down any further. So let's move on to 32. Okay, 32 can be broken down. Use your calculators. Pause the video, use your calculators. Okay, I'm getting 2 and 16. 16 then is 4 and 4, 2 and 2, 2 and 2. All right, so if I do my chart here of pairs and leftovers, I got a pair of 2s. I have another pair of 2s, and then I have this leftover 2 from up top there. So that would be 4 times the square root of 2. Okay, let's move on to this next one here. 3 times the square root of 45. 45, use your calculators again. Figure it out, pause the video, and try and break 45 down. Okay, this can become 5 and 9. 5 cannot be broken down any further, but I have a 3 and a 3. Okay, so I do my chart, pairs and leftovers. I have a pair of 3s, leftover of 5, so 3 times the square root of 5, but hold on 1 minute. Do not forget about this 3 out in front here. Okay, you got to multiply the 2 of those, and that becomes 9 times the square root of 5. Okay, so let's bring down this first term here as well. I have a 7 times the square root of 5. I'm going to bring down this minus sign here as well. And I'm going to bring down the plus sign that was in front. So now I have one big long problem for us to take a look at. So let's see where we're at here. I simplified each of them. So step 2 says combine like radical terms. And again, like radical terms means that they have the same square root sign. So let's take a look. This one has a square root of 5. Second one has a square root of 2. That doesn't match. The last one here has a square root of 5. So that means that these here are like radical terms. So I can combine them. So 7 plus 9 gives me a 16. I'm going to keep the square root of 5 there. And then this last part here, this lonely -4 square root of 2, I'm just going to tack on to the end there, okay, because that didn't match. And that right there is my final answer. Okay, so hopefully, guys, that made a little bit of sense to you. Again, if you're having questions, if it doesn't quite make sense, use the Zoom link that's there for Mrs. Wunderlich, and you can ask her some questions. But this is what you're working on next. In Google Classroom is posted the adding and subtracting radicals worksheet. Okay, there's a ton of questions there. So please make sure you're using your time wisely for the rest of class. Show all of your work on a separate piece of paper. Submit all of the work by your due date. Okay, look in Google Classroom for the due date because whatever you don't finish during class time is considered your homework as well. So please make sure you're showing all of your work on a separate piece of paper and submitting by the due date. You guys have questions, you can contact Mrs. Wunderlich if it's during the class period time. If not, please make sure that you're emailing me your questions, and I will see you guys for class again on Tuesday. Bye, guys.